Dear students, today's topic of my lecture, current electricity part 4. In it, I will explain what is potentiometer, its principle and its applications. So let us restart. First, what is potentiometer? You can see here in the diagram, a potentiometer of 10 wire is shown, each wire of length 1 meter. You see that here, this is whole apparatus is a potentiometer. There is a one black object is here, that is called jockey. With the help of this jockey, we will find out a point at which galvanometer shows no deflection. So first you understand what is potentiometer. Potentiometer basically is a device to compare potential difference since the method involves the condition of no current flow that we call null deflection. The device can be used to measure potential difference, internal resistance of a cell and compare EMF of two primary cells, or we can say that two sources. So here you understand what is its principle. Its principle is basically based on the working that, or we can say that its working is based on the principle that when a constant current flows through a wire of uniform cross-sectional area, then potential drop across any portion of the wire is directly proportional to the length of that portion. If we say that L be the length of that portion and V is the potential drop across to that length of portion, then V directly proportional to L. For omitting this proportionality sign, we require a constant, say phi or K. Now V equal to phi L or KL, where phi or K is the constant of proportionality, is called potential drop per unit length, or we can say that it is potential gradient. Now here you see that a potentiometer is there, and this potentiometer that consists of the 10 wires of 1 meter each. This is a meter scale. Its point A is connected to the battery's positive end and the negative end that connected to the rheostat. Other terminal of the rheostat connected to the key K, and other end of the key is connected to the point B of potentiometer. And other end of a potentiometer also connected to the cell of EMF E, internal resistance R, and to the one terminal of resistance box. Other terminal of the resistance box is connected to the key K dash. Other end of the key K dash is connected to the galvanometer. Similarly here, the negative terminal of the cell is connected to the here to the galvanometer, and this point of the galvanometer that connected to the jockey. So this is the circuit diagram of the potentiometer. So whatever we are saying here, the V directly equal to L, and how you justify this one? For that purpose, we know that V is equal to IR, and in place of the R is rho L upon A. So V is equal to I rho L upon A, where I is the constant current, A is the uniform area of cross section, rho is the resistivity of the potentiometer wire. So all these three factors are constant. So that's why in place of I rho upon A is phi or K, which is known as potential gradient. So V equal to phi L or KL, and it means V directly proportional to L. So whatever you are saying here in the principle that you are justifying here, yes, if constant current is flowing through the potentiometer wire having the uniform cross sectional area, then potential drop across any portion of the length of the potentiometer wire is directly proportional to the length of that portion. So this is about principle of potentiometer. Now here we plot a graph between the potential drop and the length of that portion. Then we get a straight line and that passes through the horizon. Now the first application, comparison of EMF of two primary cells by using potentiometer. So the circuit diagram for the comparison of EMF of two primary cells is shown here. You can see here. So this portion is potentiometer. Here you can see that only the 6 wire. Okay. So you can make 6 wires, you can make 4 wires also here, and same way as you have understand that this point A is connected to the battery, that is positive end, negative end connected to rheostat, other end connected to the key K1, and the other end of key K1 is connected to the point C of the potentiometer. Through this point A, we are connecting the two cells whose EMFs are E1 and E2, and their negative terminals are connected to a two-way key which consists of the three terminals. So in 1 and 2 terminals, negative terminals of cell of EMF E1 and E2 are connected, and third terminal, that is common, and through this a sensitive galvanometer along with the jockey is connected. So first we close the key K1 so that a constant current flows through the potentiometer wire with the help of the rheostat. After that we insert a plug between 1 and 3 so that the cell of EMF E1 comes in the circuit and E2 remains disconnected. And with the help of the jockey, we find a point on the potentiometer wire at which galvanometer shows no deflection. Let it be N1. Then we note the length AN1. What we are saying that it1 is L1. Then we apply Kirchhoff's voltage law in closed loop AN1 G31A. So you see that the loop's direction from lower potential to higher potential, that is from negative to positive. So that's why E1 is positive. And potential drop across AN1 is phi L1. Since galvanometer shows zero deflection, so that's why here the potential difference is zero. So finally the equation is E1 equal to phi L1 plus 0. Mark this equation 1. Similarly, now you remove the plug from 1 and 3. Now insert the plug between 2 and 3 so that the cell of EMF E2 comes in the circuit, E1 remain disconnected. Again we find a point on potentiometer wire with the help of jockey at which galvanometer shows no deflection. Let it be N2. Then we note the length AN2 which is L2. Again we apply the Kirchhoff's voltage law in closed loop AN2G32A. Again you see that direction of loop from lower potential to higher potential, that is negative terminal to positive terminal. So E2 is positive. Further you write E2 equal to phi L2 potential difference or potential drop across AN2 plus 0, that is through galvanometer as it shows no deflection. So mark this equation 2. Now divide equation 1 by 2. You will get E1 upon E2 equal to phi L1 upon phi L2. Phi get cancelled. You will get finally E1 upon E2 equal to L1 upon L2. So if you find the balancing length, then we can compare the EMF of two primary cells by using potentiometer. Now the second application, internal resistances or internal resistance of a cell by using potentiometer. Similarly, we have a circuit diagram for finding the internal resistance of a cell. This is a potentiometer. So again, The point A is connected to the positive terminal of the battery, negative terminal of battery connected to rheostat, other end of the rheostat connected to a key of K1, other end of the key K1 connected to the point C of the potentiometer. With this point a cell of EMF E whose internal resistance is to be determined connected along with key K2 and a resistance box. So first we close the key K1 and with the help of the rheostat a constant current flows to the potentiometer wire. Here key K2 remains open. So in this condition we have to find out with the help of the jockey a point on the potentiometer wire at which galvanometer shows no deflection. Let it be N1. Then we note the length AN1 so that it comes to be L1. Now you see that when the key K2 is open, then only the cell of EMF E is in the circuit. No external resistance is there. So that's why the potential difference between the two terminals of the cell is maximum. So it is the EMF. So EMF equal to phi L1. So mark this equation 1. Now we close the key K2 here. Then the cell sends a current through the resistance box. If V is the potential difference of the cell and the balance length is obtained with the help of the jockey on the potentiometer wire AN2. That is at point N2 galvanometer shows no deflection. Then we note down the length AN2, that is L2. Then V equal to phi L2, that you already studied. If external resistance is connected in the circuit, then the potential difference across to the external resistance is equal to the potential difference between the two electrodes of the cell. So that's why we say that V is equal to phi L2. Now you divide equation 1 by 2, then E upon V equal to phi L1 upon phi L2, phi get cancelled, then you will get L1 upon L2. So finally you will get this equation 3. Now we know that the internal resistance of the cell is given by E small r equal to E minus V upon I. That you know already the formula V equal to E minus I small r. So from there you are getting this formula small r equal to E minus V upon I. And but I is equal to V upon r. So that's why when you substitute here, then E minus V upon V into R. Now you rearrange it, then what you will get? Small r equal to E upon V minus 1 into R. And this is the resistance. R is the resistance that we are getting from resistance box. And this E upon V from equation 3 you substitute here. Then finally what you will get, internal resistance small r equal to L1 upon L2 minus 1 into R. So if you know the balancing length and resistance from the resistance box which is known, then we can find out internal resistance of a cell by using potentiometer. So this is about internal resistance of a cell by using potentiometer. Now the sensitivity of potentiometer, which is very important. So many concept based questions you will get from this sensitivity of potentiometer. Means a potentiometer is sensitive if it is capable of measuring very small potential differences and it shows a significant change in balancing length for a small change in potential being measured. Means what is sensitivity? Sensitivity means an instrument should be sensitive for a very small value. and potentiometer is used to measure the potential difference. So if it is capable of measuring the very small potential difference, then we say that it is very sensitive. So the sensitivity of the potentiometer basically depends on potential gradient along its potentiometer wire. And the sensitivity, how we can increase, and that we can increase by reducing the potential gradient. And the potential gradient, you know that phi is equal to V upon L. So potential gradient can be reduced either by increasing the length of the potentiometer wire, but while you are using a potentiometer which is having a fixed length, if you are using a 4 wire potentiometer, then length is fixed. If you are using a 10 wire potentiometer, then length is fixed. So if length is fixed, then how we can increase the sensitivity of potentiometer? In that condition, you know the formula phi is equal to V upon L. So when phi, or you can say that K, in some book it is represented by K, that is equal to V upon L. So L is fixed. Then what is V? V is IR. So if L is fixed, then sensitivity can be increased by reducing the potential gradient. In that condition, we reduce the current in the circuit with the help of rheostat. If we reduce the current, then potential gradient gets reduced and sensitivity of potentiometer gets increased. Sometimes you get concept based question. One graph is given between V and L, and two straight lines are drawn from the origin, and say find out which potentiometer is sensitive. So you just find out slope and calculate it, and then by this formula you can identify that which material is more sensitive. Only just remember that for making a potentiometer sensitive, potential gradient should be reduced. And there are two methods for reducing the potential gradient. One is by increasing the length of potentiometer wire. If the length of the potentiometer wire is fixed, then by reducing the current in the circuit with the help of rheostat. Now we take here one example. Here we are taking one example or the problem which is based on potentiometer, which is very important, and a lot of concepts you can get clear by doing this problem. And this problem is also asked in the CBSE Delhi. You see that here in the following potentiometer circuit AB, this AB is the potentiometer wire, right? Is of uniform wire of 1 meter and a resistance 10 ohm, means RAB equal to 10 ohm. Calculate. First, what we have to calculate? Potential gradient along the wire. And second is balancing length. Here the 2 is repeated. So balancing length AO, which is represented by small l. So you see that in the circuit, this AB, this is connected to a cell of the 2 volt and resistance 15 ohm. So this whole circuit is a potentiometer. And here at the A point, one cell of EMF 1.5 volt with its internal resistance 1.2 ohm is connected along with a external resistance 0.3 ohm with a galvanometer along with jockey. So that this point O is the balance point. AO is the balancing length, which is represented by L, that you have to calculate. So now this is about circuit diagram. Important thing is that always you remember this EMF always must be greater than to this. Then only you can get a balancing length. Now we solve this problem. First part, potential gradient phi or K equal to VAB upon LAB. That is the formula. But VAB is equal to IRAB upon LAB, and this I can be written as this is the total current that passes through the potentiometer wire. So I equal to total EMF upon total resistance R total, and this factor RAB upon LAB. Now here you see that the total EMF is 2 volt and total resistance of potentiometer wire, which is given 10 ohm, and this 15 ohm, both are connected in series. So that's why you are getting 2 upon 15 plus 10, and RAB is 10 and LAB is 1 meter. So 1. So when you solve it, you will get K equal to 20 upon 25. This is 2 into 10, 20, 15 plus 10, 25 into 1, 25. So 20 upon 25. When you divide it, then you will get 0.8 volt per meter. So this is potential gradient. Always when you find the potential gradient, then you have to use the value of EMF of the cell which is connected to the potentiometer. Remember it. And the value of this cell always must be greater than the cell which is connected to the potentiometer. Right? Now another part is you have to find out the balancing length AO. So first we will find out how much current is flowing in this circuit. Okay, because we are going to find out the balancing length here. So you see here current equal to EMF of this cell divided by total resistance of this circuit. So this is internal resistance, this is external resistance, both are connected in series. So this becomes I equal to 1.5 upon 1.2 plus 0.3. So what you are getting, the current is 1 ampere. 1.5 divided by 1.5. Now the potential drop across AO equal to IR, that is 0.3 into current is 1 ampere. So that is 0.3 volt. So you are getting the potential drop across AO is 0.3 volt. Already you have find out potential gradient. So apply the formula K equal to VAO upon LAO. And your aim is to find out balancing length LAO equal to VAO upon K. And VAO that you have calculated 0.3 and K already you have calculated 0.8. Substitute the value, solve it, you will get 0.375 meter. That is 37.5 centimeter. So this is the balancing length. So this is about one concept based, numerical based problem related to potentiometer. So this is the way to apply the concept and solve the concept based question as well as numerical. If you like my video, then like it, subscribe it and press the bell icon. Thank you and have a nice day.